there's two things there that you need to have domain knowledge about the process that you're solving. So that's more of a consulting thing and business knowledge. And that's something that data scientists are very good at. So they collaborate a lot with the business process owners. They understand what the data means. They understand how this data is generated. And they understand kind of all the constraints surrounding when is this data available, when do I need, what is kind of the window for these predictions, things like that.
Hello and welcome to a whole new episode of Engati CX. I'm your host Kingshuk, and today we have a technology expert with us on the show. But before I introduce you to our guest, allow me to introduce you to the magic of Engati. Engati is the world's leading multilingual, no-code digital CX platform available across 14 channels with 45,000 solutions created across 187 countries in pretty much every domain and use case. Engati has also been recognized as a top platform by Inc.com, Tech World, CIO, and many others. We run the Engati blog, video channel, and the Engati CX podcast, receiving upwards of 400,000 visitors annually. And now for our guest. Jan van der Vegt is the CEO of Cubonacci, where he helps organizations streamline their machine learning workflows. He's passionate about accelerating machine learning across industries. For him, machine learning solutions require two primary things: efficiency and trust, where efficiency driven by automation helps iterate over options and allows solutions to adapt to the continuously changing world. And trust definitely helps organizations to see the results. But before we dive into our interview, don't forget to subscribe to the Engati channel to get the latest and exclusive content from thought leaders from around the globe. So very welcome to our show.
Thank you.
So let's begin with the discussions. So you have been working a lot with companies around machine learning. So what do you think companies need to apply machine learning as such?
Yeah, so if you look at how a lot of companies are dealing with data science and specifically machine learning in general, you can identify kind of two stages. There's the kind of the initial research phase or proof of concept phase, where somebody who understands the business problem that you're solving or the process that you're trying to make more efficient, and understands how to process large amounts of data and learn the relationship or kind of the predictive model and evaluate how well that works. The outcome of that is usually some kind of report or an advice, or maybe just some results of, if we do this, this is the amount of money that we save, or the amount of time that we can save, or we can do this X better. But the reality is, in a lot of cases where you want to automate decision making, you actually need to go to the next phase, which is what they call industrialization. And basically what that means is that you have to integrate these models in kind of the larger picture, both from an organizational perspective, from an IT perspective. These models have to run somewhere. All of a sudden, data is not like a static thing anymore, where you have some large dump of data, but now you have to deal with live data coming in, which you have to use for predicting certain things. So there's a lot of things that entail machine learning that is more than just kind of raw data and code to learn this relationship. But that only becomes apparent in the second phase, when you want to get things to production, and that's usually the moment when you actually start generating value out of it. So it's a really important step, and companies have really gotten good at this first step. There's a lot of people coming from university learning about machine learning, and organizations understand better and better where they can get value using these new techniques with the massive amounts of data that are available. But companies are not so good at the next step yet, to actually start generating value by getting models to production. And that's something that has really been surging the last few years. You see that companies are starting to recognize that this is difficult, this is a new way of working for them. And they're figuring out what is the best way to to that next phase, or maybe get phase 1 and phase 2 closer to each other, so it's easier to transition going from this proof of concept to actually generating value out of it.
Yeah, and I think that's quite important because pretty much with any latest edge technologies, you always have the challenge of taking prototypes and putting them to production, and industrialization is the correct term, I think, for it. So and it, as you rightly pointed out, it's a lot more than data, and it's all about the infrastructure, how you manage, and things like that. So I think, yeah, some key points there. So in terms of the entire machine learning cycle, since we spoke about productionized systems, so how would you sort of help us with the key components and areas where companies need to focus?
Yeah, so MLOps in general, that's something that we'll be discussing a little bit, but is kind of taking a look at DevOps, the role of DevOps, which is a very, no, not very recent, but compared to 10 years ago, how software is developed and how that is kind of integrated and things like that has really changed with the philosophy of DevOps, which is really about getting the operations part much closer to the development part. And in a sense, it's very similar to what we talked about before, where the development is kind of the initial work, but then actually operationalizing things is kind of the next step, and the step where you're actually starting to use the or get benefits from the investment in the development part that you did. And DevOps is really focused surrounding kind of the life cycle of software, so the software life cycle. And you can kind of identify a number of stages that software can be in. If you look at a typical flow, you'll have an initial idea of, okay, we're going to build this with this purpose. You have requirements engineering there, like what do we need this software to do to help us out. Then you'll have people working on the software. It needs to integrate with other pieces of software throughout the organization. Then it's deployed initially. And that's when the first moment where you're actually using it comes in after some initial testing. And then there will be additional iterations because maybe there's bugs in there, or there's additional requirements, or maybe some integrated part with another piece of software they are updating, so you have to update the connection there. So that's kind of the maintenance part of it, where you're already running the software, but you have to keep making additions to it or changes. Oh. And eventually, for some reason, you're not going to use this software anymore. Maybe you have a very new approach to it, so you're going to exchange it for this new approach, or maybe the business process doesn't exist anymore. So then that's kind of the moment where you phase out your software, and the time between initial idea and when you phase it out is obviously very different depending on the use case. So that's how software works. And with machine learning, it's pretty similar. If you look at, if you think about a machine learning model as a piece of software, which basically it is, you can think about kind of the initial ideation, then developing the model, training a model, deploying that, iterating over it because you're retraining your models, maybe you're adding additional data sources for better predictions, and eventually you're gonna replace it with a different solution or something like that. So the only thing is there's some major differences in machine learning compared to software development, more traditional software development, and that is something why I believe a lot of companies are struggling, because the people who are building these models are usually not very familiar with building software, because it's a pretty different field. It's much more mathematical, statistical, and it's more about scripting, at least in this proof of concept phase. While the people then responsible for actually industrializing it or taking this to production are people who are familiar with more the traditional software lifecycle, but they're not familiar with the differences between the machine learning lifecycle and the traditional software lifecycle. And one very obvious case is that even if your code doesn't change, if the underlying data is changing and the underlying world is changing, like that means that you might have to retrain your model, deploy a new version of the model, even though the code hasn't changed. So other examples where there's a big difference is the fact that even if the code is ready, it doesn't mean you can just build it and deploy it somewhere. The model itself has to be trained somewhere, and that can be very intensive. Like if you're dealing with natural language processing, maybe you have huge amounts of training data, training on GPUs, and then afterwards, when the model is trained, it has to be deployed somewhere, and that's a very different requirement surrounding how it's deployed and how it's trained. So there's a number of key differences, which makes it difficult for companies to adapt to this new kind of way of dealing with the machine learning lifecycle as opposed to software lifecycle.
So obviously, you highlighted a lot of the key differences between a traditional software lifecycle versus a machine learning solution lifecycle. And also you spoke about DevOps and its requirements. So just focusing on that parts, and there is of course this term for MLOps that is now coming up. So how would you define that, and what do you think are its goals? And is it like a new skill set, or people who are doing DevOps or traditional software solutions can move over and pick up those operations from there?
Yeah, so it's just like, I think, how the machine learning lifecycle compares to the traditional software lifecycle. It's kind of how MLOps relates to DevOps. The goals are very similar with DevOps and with MLOps. I think the goals are twofold. On the one hand, you already alluded to it at the beginning. On the one hand, it's about efficiency, because there's a lot of different stakeholders involved, because there's a lot of challenges that preferably you want to automate some way. Efficiency becomes very important because efficiency allows you to iterate. It allows you to give more autonomy to your team, and it allows you to adapt much faster to changes in the world. So efficiency is one major goal of MLOps and DevOps, and the other one is really about it's about trust or confidence, and that is a wide area that touches upon a lot of parts of the process, but it means that you can trust individual predictions that are being made. It means that you can trust that the data and your models are secure. It means that it's easy to figure out if something goes wrong, like that you know about it and that you can figure out exactly what went wrong. So versioning everything, capturing all the logs, things like that are all important for generating trust in your solution. And so those are kind of two different goals, very different goals. But in a lot of cases, the trust is essential to do this well. If you can't trust your solution, your business stakeholders are not going to use it. And in some cases, it's actually you're legally obliged to have this in place, because otherwise you're not allowed to make decisions in an automatic fashion. And MLOps is kind of a philosophy or a way of working where instead of the focus, where the focus is on this kind of handover from a proof of concept to, okay, we're going to take this model that we have developed and turn it into production. It's much more about structuring your processes in a way that this can be done automatically or autonomously by the person developing the model. And MLOps means machine learning operations. So it's really about kind of the operations and the processes surrounding it. That's everything from infrastructure, to metadata management, to being able to roll back solutions. And it's really, to a certain degree, it's about a way of thinking about it, and to another degree, it's more about kind of automating as many things as possible, just to both increase the efficiency, but also make it a lot easier to manage everything and understand everything that's happening in your whole system.
Yeah. So I guess a lot of aspects and areas where we need to take care, which organizations might typically overlook, especially when they are starting off on a machine learning solution or their journey around this area. So
there's a lot of talk about scaling with machine learning, and usually people talk about compute like dealing with larger and larger data sets. Maybe it doesn't fit on a single machine anymore. But in my experience, that is not necessarily a large issue for a lot of organizations. But actually scaling as a team, like dealing with a larger amount of projects, becomes very challenging if you don't do this well. So actually the ideal or the thing that we observe most is companies that are getting their second or third model to production as a team. They start to realize, okay, at this moment we're doing something very similar to before, but what we did before we can't actually reuse. We only have some more knowledge, but it's not structured in a way that we can actually do it well once and then keep using the same solution for that. And they're starting to get to worry a bit about, okay, how are we ever as a team gonna maintain 10 or 20 machine learning models? Because yeah, if there's no process in place, if you haven't figured things out well, then it means that there's the amount of manual work to maintain things is pretty significant even for an individual project. And yeah, it's very wasteful to have to hire more people just to have more machine learning solutions in your portfolio. So yeah, with MLOps, you're kind of investing time and money in making a more scalable solution where you're trying to automate as many things so that it's easy to manage more and more with the same size team, and that way you're basically guaranteeing the longevity of your projects and the scalability of your team or your organization.
Yeah, that's true. So, so now your journey at Cubonacci. So, of course, you have seen all these challenges organizations face, as well as different stages of them adopting these solutions. So tell us more about how does your platform help these companies to sort of automate the entire life cycle and handle these complications, as you mentioned?
Yeah, so there's, as you said before, it's a fairly new field. I mean, there have been companies, of course, that have been solving this internally for a while already. The term or the word MLOps is somewhat new, but yeah, what you see is that there's a lot of ways to approach this, and as a vendor who is building a tool that has to be used by a large variety of organizations, it's maybe even more challenging than building something in-house specifically for your context. There are a few ways to approach it, and the way that we have chosen is that what we see in the machine learning world, there's a lot of obviously a lot of ways or complexities for individual projects. So there's always a lot of kind of exceptions. There's the world is changing very fast, so there's new papers coming out every day that have algorithms that fit even better with your specific use case. So being able to be flexible as a data scientist or as a machine learning engineer is important to us, because we believe that you can never keep up as a company where you're just providing the algorithms. So instead, we're providing a platform that allows our users, which are mostly the people building these models, to be flexible in how they solve their problem. So that means we're a code-first platform. Our users write Python. Python is, of course, by far the most common machine learning language. And the way that we do this is that our users supply their code using Git. Git is used for version controlling the source code, and there's a whole ecosystem surrounding that where we can connect to these code bases. And whenever a new update comes in, we get a notification, and we use that to understand what your code is doing. And because of a certain standardization, and I think standardization is a really important key aspect to doing MLOps properly. Because of the standardization, Cubonacci can reason about the role of each part of the code, but it also helps teams because they have to work in a similar way, and it makes it a lot easier to collaborate with each other and to reason about the code of your colleague, because at the moment in a lot of cases it's a bit of a wild west in companies. which also means that in many cases when a data scientist leaves and the market is fairly fluid, the projects that they leave behind are actually not easy to use again. Yeah, so that's kind of the entry point. Whenever our users make a change or they can commit that back to Git, we validate that structure is correct. It's based on best practices that people are already used to from the Python world, and whenever it's validated, then you can use Cubonacci to train these models at scale, save everything. The data snapshots can be saved and reused. All the infrastructure is taken care of, and then models can be deployed, and all these kind of things, all these steps can be automated. So that means as a data scientist, you have way more autonomy to do all these things, all the way up to getting a model to production or scheduling things to retrain every week to keep up to date with the changes in the world. But in a way that you're flexible in how you want to solve your problem, but you don't have to worry about a lot of the things that you have to keep in mind when you go from a proof of concept to production. Yeah, and we've really modeled it around, like, our target user are data scientists who are comfortable writing code, but are not engineers that are good at building software. And that's what a lot of data scientists are. And that makes a lot of sense because of where they're coming from an educational perspective and experience in their first few years of their career. Yeah, so that's how we do it, and that's a bit different than some of our competitors. But I think it really fits well with what people are good at and what they like doing, and where there's a lot of overlap between, even though you have very different cases, whether you're dealing with natural language understanding, computer vision, or time series forecasts, a lot of the things that keep coming back with regards to complexities, we take care of handling those complexities well once, so you don't have to worry about it.
Yeah. So quite a lot of things, and I'm sure your platform is very useful for organizations. And I think you pointed out very rightly that it is best to leave the people who know what they are doing and let them focus on what they know best. And you handle the rest in terms of managing and standardizing all the operations for them. So
yeah,
it's pretty useful from that perspective.
Yeah, so because if you think about what is the role of a data scientist or somebody who builds a machine learning solution, there's two things there. That you need to have domain knowledge about the process that you're solving. So that's more of a consulting thing and business knowledge, and that's something that data scientists are very good at. So they collaborate a lot with the business process owners. They understand what the data means. They understand how this data is generated, and they understand kind of all the constraints surrounding when is this data available, when do I need, what is kind of the window for these predictions, things like that. And they're good at determining what kind of algorithm fits best with their needs, how to represent their data, etc. So we want to leave our users as flexible as possible in that area so they can solve their problem well. But then everything after that, we want to automate as far as possible and allow customization where required. But just to make sure that once you have working code that solves your problem, that it's just a click of a button or commit to a certain branch, so to roll everything out so that that way you can immediately measure how well things are working, and you're just, yeah, that's the most important part, is that you get autonomy as a data science team or as an individual to solve things well, but also go fast afterwards and robust.
True. And I think a lot of reliability and data management aspects also come in, because I'm like, a lot of the data is maybe private data and there might be safeguards around it. So I think a standardized solution and operations layer where they don't need to worry about those aspects is really helpful. So I'm very curious about how you guys started and what was the initial thought process, because most of these machine learning companies would pick up a solution and build focus models or packages around it. But you have chosen to solve this particular problem that pretty much everyone faces, but nobody really takes the effort to go out and solve. So what was your motivation?
Yeah, so it was kind of plural. I worked at KLM before, one of the major airlines in the world, from the Netherlands. I worked there for 3.5 years, and initially I really focused on in-depth machine learning, on how to apply these algorithms, mathematical algorithms, to predict many different things, whether it was about recommending the best destination based on your history, or predicting the probability of certain delays for a certain flight. Machine learning was a very good case for a lot of these things within the airline domain. And I really enjoyed that. I learned a lot about that. But over time, I started to realize also, when I was coaching some others, I realized that the challenges was not as much about learning these predictions better, or these models better, but more about actually then applying the results that you were having in an automated fashion. And because of that, I shifted a bit from the machine learning side more and more towards engineering, and more on a strategical level. KLM hires a lot of data scientists, and thinking about, okay, how can we design the process in a way that makes it easier for people to not have to take 6 to 12 months to get something to production. And based on what I was observing, and a lot of conversations I had with my colleagues, I started looking for possible solutions that were out there. There were a number of open source kind of projects that were related, but nothing really fits with the way I envisioned how to do this, and in a way that focuses on the core strengths of data scientists, because a lot of these tools are more focused on developers or engineers. And so we made the decision to build something internally as opposed to buying something, because the few commercial solutions that were available back then really didn't fit kind of the challenges that we were facing, and the way that I envisioned how to solve that. So that's how I got involved. I started a project that was going to solve 2 or 3 of these kind of sub challenges that we've been talking about a bit. And very focused on that team that I was part of. But eventually I decided to, I was so kind of obsessed with this problem, and I have a pretty big network. I talked to a lot of people outside of the KLM organization, and I realized that kind of my ideas resonated with a part of the people that I talked to, and there was still nothing on the market for that. So I decided to quit my job, talk to some people, and get started with Cubonacci to kind of rectify the fact that there was no solution in this kind of area yet. So that's how I got started. I also had a need for a sense of for entrepreneurship for a while already. So I was also interested just in building something from the ground up. So that combination I felt like that was the right moment, because it was getting clear that companies were starting to realize that the way they were doing machine learning now is not sustainable, and not kind of. It was very obvious that in 5 years later, the world was going to be very different with regards to how machine learning was working, and so I believe there was a lot of opportunity there, but it's clear that companies are spending a lot more time on this challenge, and so things are going well, and so I'm really happy with the decision that I made 2 years ago.
Great. Wonderful story. I mean, it's always amazing to see someone like, as you mentioned, being so engrossed by the problem that I guess you had no option but to start it at that time and solve this for everyone. So really wishing all the very best to you and what you are doing as a team. And definitely a lot of insightful topics that we touched upon. I'm sure our audience is going to love this interview. So thanks a lot for spending the time with us. So yeah.
Always. Thank you for having me.
Yeah, thanks. So we will be back with a new episode with a brand new expert soon. So stay tuned and look to see you for the next one.